Hi, we are Group 10 and this is our semester project for data mining. For our project, we have performed data mining and unsupervised machine learning techniques on the Yelp dataset. The team consists of myself, Xiwen, and my teammates.
Hi, I'm Emily Duta.
Hi, Tony.
Hi, I'm Vaishal.
Over the semester, we wanted to answer the following questions. What neighborhood, if any, have the best selection for a particular cuisine in a certain city? There are some areas in a city that are more upscale or diverse than others. Based upon user reviews in a particular city, can we recommend a particular dish at a top restaurant? And finally, what topics are discovered frequently in reviews and do they correlate to a positive or negative review? The team wanted to look into those questions in hopes of giving new insights and improving the experience for business and customers. The dataset consists of 4.7 million reviews over 150,000 business and 12 metropolitan areas. For the scope of this project, we mainly focus on Pittsburgh, Pennsylvania, which has roughly 2,000 restaurants, 53 neighborhoods, and 43 different cuisines. The following methods and techniques were used in our project. For pre-processing, we use tokenization, legitimization, filtering, and steaming. With respect to our unsupervised learning techniques, we covered clustering, a recommendation system, and topic modeling. I will pass it to Emily to cover clustering.
To discover what neighborhoods in Pittsburgh may be known for a particular cuisine or attribute, we performed 3 clustering techniques: K-means, GMM, and dbScan. K-means and GMM produce the better results, so we'll focus on these methods. To get a quick idea of the neighborhoods we're looking at, here's a scatter plot of Pittsburgh neighborhoods. The downtown area is known for its nicer restaurants, and the Bloomfield neighborhood is known as Pittsburgh's Little Italy. We were hoping to find these clusterings in our results. The restaurants with no neighborhood tag in red were filtered out for our analysis. We took a look at the closeness and the similarities of the restaurants by using the longitude and latitude and the cuisine or attribute. To pick the number of clusters, we used the elbow method, as seen in the top left, plotting the error versus the number of clusters. 4 was selected due to the bend. The silhouette score was used to validate the consistency within the clusters. Since the value ranges from -1 to +1, our value of 0.29 wasn't too promising. For GMN, when we increased the number of components to 15, which was the number of top cuisines, the silhouette score slightly increased. With this visualization, we can start to see Little Italy. We consistently saw the southwest area labeled as Italian, but overall, our results indicated to us that there doesn't seem to be many neighborhoods within Pittsburgh that are known for a specific cuisine. The more interesting results were identifying neighborhoods according to their attributes, such as upscale, divey, casual, or touristy. This time received a higher silhouette score of 0.38. When we compared these labelings to an external source of household income by neighborhood, the results seemed to correlate. Here's Tony to talk about the recommendation system.
Besides the clustering analysis, we also built up our recommendation system. We made up the utility matrix by extracting the business ID, user ID, and the rating star for each review. To represent the similarity between each pair of elements, we used the cosine distance. To make the computation more efficient, matrix operation is also employed. For the evaluation part, we used the MSE, which is the mean square error. And based upon this, we built an evaluated item-based and user-based recommendation system using K nearest neighbor. Here are the relationship between MSE and K for each recommendation system. We can easily find out that the user-based one performed better, and consider the computational efficiency. 75 is a good K to be used for the user-based recommendation system. Besides this, we tried several methods to improve our performance of the recommendation system. One of that is to make the helpfulness into consideration, which is a logistic function of the number of the user who think the review is helpful for them. The detail about why we chose the logistic function is explained in the report. After adding the helpfulness score as weights to calculate the predicted value, the score user-based recommendation system seemed to perform better than the original one. We built the demo recommendation system based on the k-nearest user with helpfulness score. Here's a showcase. For the 199 users, we got the 5 restaurants to be recommended.
Thank you, Tony. Hi, I'm Vaishal. I'll be talking about topic modeling. We are going to perform topic modeling using LDA model. Before doing that, we are going to perform sentimental analysis to classify positive and negative reviews. We are using Google Cloud Natural Language API to perform sentiment analysis. When you give a review, Google API returns with a score and a magnitude. Score determines whether the review is positive or negative. If the score is greater than 0.25, the review is positive. If it is less than negative 0.25, it is the negative. Anything in between is a neutral review. Magnitude determines the overall emotion of the review. This is a plot of sentiment distribution of reviews for different restaurants in Pittsburgh. This plot gives a brief overview of how many positive reviews, negative reviews, and neutral reviews each restaurant has. We are using LDA model to perform topic modeling or to discover hidden features in our reviews. LDA assumes that each document consists of a mixture of topics and each topic is a distribution of words. So each word can be represented in multiple topics. Each document can be represented as a vector of all its words. Collection of reviews together can be represented as document term matrix. LDA uses matrix factorization technique to represent document term matrix as product of document topic matrix and topic term matrix. While performing LDA, we need to choose a number of topics. Topic coherence can be used to find optimal number of topics. Topic coherence indicates the score indicates the pairwise word similarity of words within a topic. Higher the coherence score, better would be the model. After analyzing this graph, we can see that when the number of topics is 12, coherence score is very high. So we are performing LDA model with 12 topics and we generated word clouds. So here we have picked 4 different word clouds and displayed it here. So each of these word clouds, the font size represents the frequency. Each of these word clouds discuss about different topics, as you can see in here. Since the topics are probability distribution of words, we can see that words like food can occur in different word clouds here. To analyze all the topics, we are going to use a better visualization tool called LDA visualization. This is Python visualization tool, LDA tool. It consists of 12 topics, each represented by a circle. Higher the area of circle, it would indicate that there are more number of words in the topic. Nearby circles would indicate the topic consists of similar words. The distance between topics is calculated using Jensen-Shannon distance. It is a distance similarity measure used for the probability distributions. Length of the bars indicate the frequencies of the words in each topic. When you click on a topic, you can see all the words right next to it, highlighted in red color, the frequencies. The similar kind of analysis can be also be performed on positive reviews. Thank you for listening to us. To check out our full report, please click at the link below.